Hello everyone, we're Team 3 and we are gonna introduce Grammar and Science Part 3. Before we talk about tree diagrams, we first learned about something called arrow notation. Arrow notation shows how we apply rules step by step to create strings. But here's the problem. Depending on the order we apply the rules, we can get many different derivations. Even the final result is the same. That can get really messy. So to fix this, we use something called tree diagrams. A tree diagram is a simpler and abbreviating way to show how a string is built using grammar rules. It doesn't focus on the order of rule application. Instead, it shows the overall structure. So how do we make tree diagrams? Let me explain with an example. First, write down the symbol S, and then pick any rule that can be used to rewrite S. Like this, and then write the symbols that appear on the right-hand side of the rule beneath S and connect them S by lines. Like this, and then repeat the procedure with the symbols that now appear beneath S. And then continue this way until no more symbols can be added. The string of words at the bottom of the tree is the sentence that we are trying to generate. It is sometimes called the terminal string of the tree. Tree diagrams ignore the order in which the rules are applied, so it abbreviates the family of alternative derivations that differ only in order of rule application. Then I will explain some terms about tree diagrams. First, the points in a tree that are labeled by categories like S and V, or words like Maggie, cars, are called the nodes of the tree. And then the lines that connect nodes are called the branches of the tree. And then the single node at the top is called the root node of the tree. And then the nodes at the very ends of the branches, that is the word, are called the terminal nodes or leaf nodes of the tree. We also need terminal nodes for talking about a given node in relation to other nodes in a tree. The node that appears immediately above a given node is its mother node. In here, S is mother of MV, and NV is mother of Maggie and Curse. And then, the nodes that appear immediately below a given node are its daughter nodes. MV is daughter node of S, and Maggie and Curse of daughter node of MV. Nodes can have at most one mother, but it can have more than one daughter. Two nodes that have the same mother are called sister nodes. And let's practice. First, what is root node in here? S is the root node. And next, what are the leaf nodes?
Maggie cheese bar.
And then, which node is the mother of Maggie? And then, which node is the daughter of Maggie?
No.
And which node is the mother of the right-hand end?
VP.
And then, which node is the daughter of the right-hand end?
Art.
And which node is the sister of the left-hand end?
VP.
And which node is the sister of chaste?
No.
No sister.
And last, which notes are the daughters of S?
NMVP.
Right, and then if you are given a set of rules and a tree, it's easy to determine whether the rules generate the tree also. Whether the rules generate the tree, likewise, if you are given a tree, you can easily determine a set of rules that would generate it. Then let's verify this. First, start with the top node S. It has the two daughters N and VP. To produce this part of the tree, we therefore need S and V in set of rules. And then we can check that N V is in there. And next, then go to N node. It has the single daughter Bert. To produce this part of the tree, we need the rule and Bert. And we can check this. Next, take the VP node. It has the two daughters VN. To produce the part of the tree, we need the rule VP is VN. We check this too. So we can tree diagrams ignore the order in which the rules are applied, so we abbreviate the family of alternative derivations that differ only in order of rule application.
Last unit, we studied that applying rules in different orders can lead to generating different derivations, but also different structure rules in tree diagrams can lead to different derivations. For students who can't get what I am talking about, let me explain this with some examples. Look at the following rules on the monitor. How many different tree diagrams can you write for this sentence, Homer chased Bart, given these rules? The answer is 2. Because there were two different structural rules in the beginning, the SNVN and SMVP, and because they use different rules, two different tree diagrams are made even though they have the same result sentence, Homer chased Bart. SMVN derivation progress like this. SNV and SNVP derivation progress like this. Unfortunately, we will not talk about which structural rule is better at generating the sentence in this unit. However, by this process, we can analyze that having more than one tree diagram is said to be syntactically ambiguous. Syntactic ambiguity means that the grammar provides more than one way of generating the sentences. In short, it means the grammar has more than one derivation. All you have to remember is that syntactic ambiguity is different from semantic ambiguity. Semantic ambiguity is something that a sentence has more than one meaning. Yeah, some kind of sentences such as, the chicken is ready to eat. However, you cannot say that these two ambiguities are the same because not all syntactic ambiguous sentences have more than one meaning.
According to the text, grammar is not just a list of rules, but a theoretical system that generates expressions in a language. In other words, if a set of rules can produce all the phrases and sentences in a language, we call that set a grammar for the language. This leads us to the following progression: rules, grammar, theory. First, we observe certain expressions in a language and form a set of rules. If those rules can generate the full range of acceptable expressions, then we consider it a grammar. And once it explains the speaker's knowledge, it becomes a theory, a candidate for a scientific explanation of what people know about their language. But where does this theory come from? It begins with a guiding hypothesis that people internalize a grammar, a set of rules, when they acquire their native language. It comes from us, from the grammar we naturally know as native speakers. We internalize grammar without being taught. It's tacit knowledge and hidden like a black box. Linguists build theories based on this, trying to explain what's inside that black box. That's why grammar isn't something we memorize, it's something we discover. By studying how people speak, we uncover the hidden structure behind language. Then, if grammar is hidden in our minds, how do we study it? The answer is we look at how people judge sentences. Native speakers can tell if a sentence sounds right or not, even if they don't know why. These intuitive judgments become data for linguistics. From this data, they form hypotheses about what grammar rules people must have internalized. So, our feelings of a language, what feels natural or not, are actually scientific clues to what we know deep down. In the end, grammar is not something we simply memorize. It reflects the deep structure of how our minds progress language. By analyzing what feels natural to native speakers, linguistics uncover the hidden rules we unconsciously follow. This turns our everyday language intuition into a powerful tool for scientific discovery, revealing that the knowledge we take for granted is more systematic than we think. Thank you for listening.